Good morning, students. So, how are you all doing? Hope you are doing good. And yes, and I welcome you all to APJ Academy. So, in the last class, we have discussed about the Bohr atomic model, which is one of the important topic, and we also have discussed about the different applications of Bohr atomic model, and also we have did certain problems or certain numericals related to that. Hope everything was clear for you. So now we are going to discuss the new topic from this chapter. Before that, let's get started with some introduction regarding our academy, our course. So we are providing a full year course, and a full year course with full academic completion. That is, we will be completing, if you are writing NEET examination, we will complete thoroughly, we will complete all the topics from our NTA syllabus, which is provided by the NTA, and also along with that we will be providing you the PDF materials, the test series, and there will be query solving. So all kind of support is given to you. Okay, you can read the details regarding the full course over here. And now also the most important feature is that we only provide this just for $490 per month. Okay, so this is a very good opportunity. You can crack JEE NEET in your comfort, at your home, listening to the classes just for ₹490. That's the most attractive feature. Okay. Yes, Protej, good morning. Hope you are doing good. Okay. And here we have free classes in YouTube. You know that if you are viewing the channel for the first time, you can subscribe to the channel because we regularly provide free classes on YouTube. Okay. So that's about me. You can read what I am, who I am. Okay. What my credentials are. You can read it over here. Yes. Now we'll start with the new topic, that is spectrum. So spectrum is an interesting topic and you can expect many questions from this also. Okay, you cannot leave the spectrum because spectrum is very interesting, and it consists of, it's also, spectrum also is an application of Bohr model, right? Because the hydrogen spectrum is what you study, right? So, and Bohr has explained how this spectrum lines is formed, all those things. So first of all, you have to understand what a spectrum is. Actually, we know that electrons absorbs energy and electron releases energy when it excites from one energy shell to another energy shell. That you have studied in the Bohr model. In the last class, we have discussed about that. Electron only absorbs or releases energy when it excites from one shell to another energy shell. Okay, or it comes back to the higher energy shell to lower energy shell, it releases energy. This is what happens with the absorption or releasing of energy related to an electron. And also one more thing you have to understand is that there are these energies are emitted or absorbed in the form of photons, and these photons, when they are trapped in a photographic plate, they provide certain patterns, or they show certain patterns, or they show certain photographs, and these photographs is called as spectrum. Okay, these photographs can be visible, and majority of these photographs or these spectral lines are not visible with our naked eyes. So we need special instruments to see those spectral lines. So I hope you got the clear picture about what a spectrum means. Spectrum is simply a pattern, and that pattern is obtained based on the energy or the photon that is released by the hydrogen atoms. Okay, So when you pass certain energy, so let's come to the classification of spectrum. From there you will get a clear picture about what the spectrum is. So let's read this definition first. When a radiation is passed through a sample of hydrogen atoms. So if you pass a radiation through sample of hydrogen atoms, you will see a pattern that is obtained on the screen, and that is called as a spectrum. So there are two types of spectrum. First of all, I'll explain this. Okay, only after clearly explaining this I will move to the next. Okay, don't worry about that. So let me take a sample here. Consider this is a container where it is filled with hydrogen atoms. Okay, and I have placed a screen over here. Here I have a screen. Yes. Okay. Now here we are passing certain radiations. Okay. Now we are passing certain radiations through this sample. We know that some of the radiations will be absorbed by the hydrogen atom. So some of the radiations will be absorbed by the hydrogen atom. That means some of the radiations will not be absorbed by hydrogen atoms. So those radiation will passes through the sample and will hit on this screen, and we will get a corresponding pattern with regards to the energy of that radiation. So this pattern we call it as absorption spectrum. Why I call it as absorption spectrum? I'll explain. Because you know that we have taken a sample of hydrogen atoms. We pass certain radiations, and some of the radiations is absorbed by hydrogen atoms. Okay, and some of the radiations have not been taken by the hydrogen atom or not absorbed by hydrogen atoms. So you have to consider what are those radiations which are not absorbed. Those radiations which are not absorbed are the similar radiations which are been already absorbed by hydrogen atoms. So when it comes for the second time, the hydrogen atoms do not absorb that radiations. So what happens? So it will just pass through the sample and we obtain a spectrum, or we obtain certain lines. That lines can be ultraviolet lines, lines can be visible lines, that lines can be infrared lines. It is based on the energy of that particular radiation. So that we obtain on the photographic plate. So that photographic plate is now showing us the absorption spectrum, not the emission spectrum. It is the absorption spectrum. That means the energy absorbed by the hydrogen atom, the similar energy has been passed through it. So it do not absorb the same energy again. So we obtained a photographic plate, and we obtained a what you call a photograph, or you can say a pattern, and that pattern is called as the absorption spectrum. Hope that is clear. Now come back to the emission spectrum. So we know that some of the energy have been absorbed by the sample. What happens when the energy absorbed by an atom? You know that the energy is absorbed by the electron. So what happens is that we know that if this is hydrogen atom, this is the nucleus, and this is the first shell or the valence shell of hydrogen atom, and we know that an atom consists of infinite number of shells, but we only consider about what? We only consider about the valence shell, as it contains the valence electrons. But you have to understand there are infinite number of shells. Now what happens is that as soon as the energy is absorbed, this electron will move up. This electron will move up. That is, after absorption, the electron jumps to the higher energy shell. And after some time, this electron will jump back to the first shell by releasing certain amount of energy. So by releasing certain amount of energy, the electron jumps back to the first shell or the first orbit, and this energy is trapped on the photographic plate, and this energy is called as the emission spectrum. So actually this is the energy or the radiation emitted by hydrogen atom. Previously it was not that. Previously it was certain amount of energy have been absorbed by hydrogen atom and some of the energy have not been absorbed by hydrogen atom. That is what we obtained here, we got here. So that spectrum we called it as absorption spectrum, because it was the energies that was left out after the absorption of hydrogen atom. Okay, so we got absorption spectrum like that. And similarly, we know that if an energy is absorbed, the electron will excite to higher energy shell. So soon after some time, the electron will come back to the normal state or the ground state. So when it comes back to the ground state after absorption, it will releases energy, then only it can come back. We have discussed that in the previous class. So now we receive certain radiations emitted by the hydrogen atom. That radiation we will trap in the photographic plate and we could see there is a photograph, or we could see there is a radiation pattern, and that pattern is called as spectrum. Hope that is clear, students. So we have two types of spectrum. One is emission spectrum, the other one is absorption spectrum. So absorption spectrum is a spectrum that is provided after the absorption of energy. When you passes certain amount of radiation through a hydrogen sample, it absorbs certain amount of energy and it do not absorb certain amount of energy, and that radiations which are not absorbed by the hydrogen atoms are trapped by a photographic plate and we obtain a pattern, and that pattern is called as absorption spectrum. After absorption, electrons get excited to higher energy state, and then it comes back, it emits certain amount of energy, or we can say the same amount of energy that is absorbed by the hydrogen atom is released by the hydrogen atom or is emitted. And if the emitted energy or the radiation is trapped on the photographic plate, then you are obtaining emission spectrum. So this is the basic difference between emission spectrum and absorption spectrum. Is that clear? Yes. Now we will move on to the next one. So here is the basic example of two different types of spectrum. See, we see certain spectrum of sunlight which is continuous, that is continuous emission spectrum, because sunlight, we know that the light or the energy is emitted by the sun, and when this emitted radiations passes through a screen of water or humidity or water vapor, what happens? We could see certain patterns in the atmosphere, and these patterns contains 7 colors, and we call them as a rainbow. And understand, this rainbow is an emission spectrum of sunlight or emission spectrum of sun. We could see the VIBGYOR. And what you also see is that you will not see any gap between each color bands. We know that in the case of VIBGYOR, we have violet, indigo, blue, green, yellow, orange, red. There are 7 colors. And these 7 colors are seen as a band or a strip. And this strip is completely continuous. There is no gap. There is no gap between the strips or the bands or the spectrum. So we know that the sunlight provides a continuous emission spectrum because there is no gap between the bands. Okay, it is the energy is so closer to each other, that is, we cannot see any gap between the emission spectrum of sun. Now if you consider the emission spectrum of hydrogen atom, it is discontinuous. It is not of the similar energies. So if there is a large difference between the energy of radiations, then obviously there will be a gap. There will be a gap between the spectral lines. So if I obtain one spectral line corresponding to a certain energy of radiation, and if I obtain another spectral line of certain energy of emission, then obviously if the energies of both the radiations are of large difference, then we will see a gap, a proper gap between the two spectral lines, and that gap shows that the emission spectrum is discontinuous. It is not continuous, in fact it is discontinuous because there is a gap between two spectral lines. Yes, okay. Now we'll move on to the next one. See, now let's learn what hydrogen spectrum is. Okay, we are going to discuss about the emission spectrum. If you have any doubt till here, you can just ask me in the comment section. Okay, now let's see. So in the case of hydrogen spectrum, before going into that, yeah, that's already we have taken, right? About the sunlight and all we have already given. Okay, now we know that in a periodic table there are 7 periods. Okay, so what do you mean by 7 periods? 7 periods corresponds to the 7 shells. Okay, that means in the first period you have hydrogen and helium. That means the valence shell of the hydrogen and helium is the first shell. In the second period you have 8 elements, and these 8 elements have their valence shell as the second shell. Second shell is their valence shell. So likewise for the 7th period, the valence shell is the 7th shell. So we know that there are 118 elements till now. So all these elements have a maximum of 7 shells, at least a maximum of 7 shells. And the 7th period are those elements which have electrons present in the 7th shell. So now we are going to consider that there is a maximum of 7 shells. Okay. So corresponding to 7 shells, let me draw this. So this is the first shell. So I'll name the first shell as K. This is the second shell, and that is L. This is the third shell, that is M. Fourth shell, N. Let me draw it a little more bigger. A. Yes. So first shell is K shell, L shell, M shell, N shell. Now, yes, this is O shell. P shell, K, L, M, N, O, P. The last one is 6th shell, that is Q. 7 shell is Q. Okay. Now we are going to discuss about the emission spectrum. Okay. We are going to discuss about the emission spectrum. So I have already told you emission spectrum is or emission spectrum is those spectrum which we obtain when an electron from higher energy shell jumps to the lower energy shell. So let's start with the highest. So if imagine that if an electron is present in the 7th shell, so now it is jumping straight to the first shell. Okay, that can be possible. Now think that if the electron is present in the 6th shell, then it is jumping straight to the first shell. Now likewise 4 to 5, 4 to 1, now 7 to 1, 6 to 1, 5 to 1, now 4 to 1, 3 to 1, and finally 2 to 1. So these are the possible emission lines which can see when an electron jumps from higher energy shell to the first shell. Okay, so if an electron is jumping from higher energy shell to first shell, we can possibly have almost 6 spectral lines. Okay, 6 spectral lines, because we know that we have only 7 period elements. That means the electron present in the 7th shell jumping to the first shell, so we will get the first spectral line. In 6th shell jumping to the first shell, we get the second spectral lines. Likewise, we will obtain 6 spectral lines. Yes, Protej, you can get the notes. you can join our Telegram group. Okay, there you will get the notes, right? So likewise you will get 6 spectral lines, right? And these spectral lines, once we obtain these spectral lines and when we studied practically, we understood that these spectral lines are of UV region. That means they are not visible with our naked eyes. Okay, and we call them, these series of lines, we call them as Lyman series. We call them as Lyman series. We have divided the spectral lines into series, different series, based on to which shell the electron is jumping. Okay, if the electron is jumping to the first shell, then that series is called as the Lyman series. Whether it jumps from the 7th to 1, 6th to 1, 5 to 1, 4 to 1, 3 to 1, 2 to 1, all the spectral lines comes under Lyman series, and we obtain that all those spectral lines have UV radiations. Okay. Now let's move on to the next case. Now that is regarding the first shell. Okay, if the electron jumping to the first shell, we get a spectral line which is of the nature of ultraviolet radiation, and we call them as Lyman series lines. So here you can see that a maximum of 6 lines are possible from Lyman series. 6 lines are possible from Lyman series. Now coming back to the next series, that is, if an electron jump from 7 to 2, then 6 to 2, then 5 to 2, 4 to 2, and 3 to 2. Now this is the visible lines. These spectral lines are visible region, are in the visible region. That means if the electron is jumping from higher energy shell to the second shell, then we can see a radiation, and that radiation will be colorful. We can see with our naked eyes. And we call this series as Balmer series. These spectral line series as Balmer series, and you have to understand that Balmer series is the very first series which is discovered by the scientists. The logic is very easy for you because these are the lines which are visible with our naked eyes. So this should be the one which is first we have discovered it. Okay. Now let's move on to the next series, that is, if the electron jumps to the third shell. Now from 7 to 3. So before that, how many maximum number of lines is possible from here? We can see that 3 plus 2, 5 lines is possible. 5 lines is possible. Now let's move on to the next series. 7 to 3, 6 to 3, 6 to 3. Now, oh, no problem. 7 to 3, 6 to 3, now we have 5 to 3, and the last one is 4 to 3. So these series we obtain, that is IR region, that is infrared region. It is not seen by our naked eyes. Okay, and this series we named it as Paschen series. Paschen, Paschen, Paschen series. So see here, for Paschen series, you can see that what is Paschen series actually? When the electron is jumping from higher energy shell to the third shell. If it is jumping to third shell, then we will get a spectral line, and that spectral line is the part of Paschen series. So here we will obtain a maximum of 4 lines. Now let's move on to the next one. The next series will be if the electron jumping from 7th shell to the 4th shell. 7th shell, 6th shell to the 4th shell, 5th shell to the 4th shell, and this series again is infrared region. This series again is infrared region, and it is called as bracket series. It is called as bracket series, and this series contains a maximum of 3 lines. 3 lines. Okay. Now the next one is 7 to 5, 6 to 5, and this is again an IR region, and this series is called as fund series. Fund series. So fund series are those series in which we obtain the spectral lines when the electron from higher energy shell jumps to the 5th orbit or the 5th shell. So here it consists a maximum of 2 lines, just 2 lines. Now I am going to give you one more which is not mentioned in NCERT, that is called as the Humphrey series. So that is just the electron jumping to the 6th shell, and it is the only one line is possible there, and this series is called as the Humphrey series. Humphrey series and Humphrey series, and this line is also from infrared region. Infrared region. So this is all about the emission spectrum. Hope this is clear. There are a lot of data, so this is what you have to understand. In the Lyman series, it is ultraviolet region. We can obtain a maximum of 6 lines starting from the 7th period. Okay, 7th shell. Now then the second one is Balmer series, where the electron jumped to the 2nd shell, and this Balmer series is what? They are visible region, and we can observe the radiation, we can see the color of the radiation in that scenario. Then IR region or the Paschen series. Paschen series is the series which we obtain when the electron jumps from higher shell to the 3rd shell, and we have bracket series, that is from higher shell to 4th shell. Then we have fund series, higher shell to 5th shell, and all these regions, Paschen, bracket, fund, Humphrey, all these series are IR regions. So the first Lyman series is UV region, second Balmer series is a visible region, and all the other 3 or 4, Humphrey is not normally asked, so all the other 3 regions are IR regions. This is what you have to understand. Now let's move on to the next one, and this is, I just tabulated what I have shown you just now. Here you can see for Lyman series we have UV regions, and the N2 value can be 2, 3, 4, 5, 6 and 7, maximum of 7. And the N1 means to which shell it jumps, so N1 should be 1. So if N1 is 1 and N2 is 2, 3, 4, 5, 6, 7, then obviously that series is called as the Lyman series. So always remember about the value of N1 for Lyman series. For the value of N1 for Lyman series is 1. So in order to find out the number of lines, you can just use this formula N2 minus N1. So for the case of Lyman series, N1 is equal to 1. So if I say that the electron is jumping from 7th shell, how many lines can be formed? See, just I am giving you an example to clarify your concept here. So let's see here, 1, 2, 3, 4, 5, 6, 7. So you have to understand that if an electron is jumping, see, this is a very important concept, don't get confused. If electrons are jumping from 7th shell, so there will be some electron which can jump from 7 to 1st at a time. But there are certain electrons which will be held here. There will be certain electrons which will be held here. There will be certain electrons which will be held here, and there will be certain electrons held here. So this is what you have to understand. If the electrons are jumping from 7 to 1, then all the possible cases also you have to draw. That is, there can be another possibility that electrons are present in 6 and it can jump to 1. That is, we know that all the electrons are present in the 7th shell, but as it jumps, always the electrons have various kind of energy. So as it jumps, it may jump to 6, or it may jump to 5, or it may jump directly to 1. So all the possibilities you have to draw. Now from the 4th shell also there will be electrons will jump to 1, then 4th shell, 3rd shell and 2nd shell. So that means the number of lines when electrons jumps from 7 to 1 is how much? N2 is equal to 7 and N1 is equal to 1. That means 6 lines will be formed. If you are asked to find out the number of lines present in the Lyman series when it jumps from 5, Then your N2 value is 5 and N1 will always be 1 if it is Lyman. So that we will be obtain 4 lines. Okay, so that is the difference. You have to be very careful there. Normally students make a mistake that if an electron jumps from 7 to 1, they will write it as, if an electron is jumping from 7, then they will write it as number, when they are asked to find out the number of spectral lines, they will write it as 1. Because they write it as 7 to 1, only one line. No, 7 to 1 means some electrons will jump directly from 7 to 1. Some electrons will jump to 6, then to 1. Some electrons will jump to 5, then to 1. Some electrons will jump to 4, then to 1. Likewise it goes. So all the spectral lines will be possible there. Okay, that should be kept careful. You have to be very careful regarding that. That's how you make the concepts clear. Now we'll move on to the Balmer series. If you want to find out how many lines are present in Balmer series, the equation is N2 minus N1. So N2 can be any value which can be given in your question paper, but N1 will be 2. If it is Balmer, then N1 will be 2. N1 should be 2 if it is Balmer. So N2 minus 2 will give you the number of lines present in the Balmer series. It can only have a maximum of 5 lines, right? Because the maximum value of N2 can be 7. So if it jumps from 7 to 2, then we can have 5 spectral lines. 7 to 2, one line, 6 to 2, another line, 5 to 2, another line, 4 to 2, another line, 3 to 2, another line. So 5 lines can be possible. Next is Paschen series. So see, in the Paschen series, we know that N1 is equal to 3. So you can find out the number of lines in the Paschen series. N2 can be 4, 5, 6. If N1 is equal to 3, then N2 cannot be 3. It should be greater than 3. Okay, so 4, 5, 6 can be possible. For the bracket series, similarly, N1 is equal to 4. So N2 can be 5, 6 and 7. So the number of lines in the bracket series is equal to N2 minus 4. Similarly, in the case of fund series, you have N2 equal to 6 or 7 and N2 minus 5 will give you the number of lines in the fund series. Okay. Now see this. Here in the Paschen, bracket and fund, we have IR regions. We have IR regions or IR lines. For the Balmer, we have visible, and for the Lyman, we have ultraviolet. Hope that is clear, students. Now let's move on to the next one. So first line of any series is called as the alpha line. First line of any series. So see, if we are considering the emission spectrum, then if the electrons are jumping from 7 to 1, then obviously 7 to 1 is your alpha line. That is the first line. Then 6 to 1 is your beta line. Then the next one is your gamma line. So up to third line, we normally give the names, that is alpha, beta and gamma. So first line is the alpha line, second line is the beta line, and third line is the gamma line. Now let's discuss about the calculation of number of spectral lines or total number of possible lines. See here, total number of spectral lines. Formula I am giving, total number of spectral lines is equal to N2 minus N1 into N2 minus N1 plus 1 divided by 2. See, what do you mean by total number of spectral lines? Just before, we have discussed that the number of spectral lines in each series. Okay. Now here we are talking about the total number of spectral lines that can be possible. Not in each series, but total. So let's see, if I give N2 is equal to 7 and N1 is equal to 1. So what will be the answer? So 7 minus 1 into 7 minus 1 plus 1 divided by 2. I'll be getting a value of 6 into 7, 42, 42 by 2, that is equal to 21 lines. A total of 21 lines. So we will check it with the previous slide. Let's check it with the previous slide whether it is correct or not. See, here we have drawn all the lines, okay, from 7 to 1. Okay, now let's check this. Here in the first Lyman series we got 5 lines, then 6 lines, then we got Balmer series 5 lines. Then in the passion series we got 4 lines, and in the bracket series we got 3, then 2, then 1. Just count all those. 6 plus 5, 11, 11 plus 4, 15, 15 plus 3, 18, 18 plus 2, 20, 20 plus 1, 21. So we got a total of 21 lines, and this is the formula which made it easier. So by applying this formula, you will get the total spectral lines if electrons jumps from 7 to 1. Okay, hope that is clear. Don't get confused. Now I am going to teach you how to find out the number of spectral lines in each series. Okay, let me rub this. The example one, but formula I will keep it there. Yes, this is 2. Okay. Now, number of spectral lines which falls in a particular series. Number of spectral lines that falls in a particular series. That falls in a particular series, that is equal to n2 minus n1. That is what we have just explained in the previous slide, that is this slide. If you want to find out the number of lines in each series, you should know the value of n1. Then you can easily find out how many lines is present in each series. Okay. Right. Now let's see this. Let's do this question. In hydrogen spectrum, if electron moves from 6th to 3rd orbit by transition in multi-steps, then find total number of spectral lines. So if you are asked to find out the total number of spectral lines, you have to use the formula n2 minus n1 into n2 minus n1 plus 1 divided by 2. So here you know that n2 is 6, n2 is 6 and n1 is 3. So you can write it as 6 minus 3 into 6 minus 3 plus 1 divided by 2, that is 3 into 4 by 2, that is equal to 11. You will get the answer as 11. Sorry. 3 into 4 is 12. 12 by 6 is 12 by 2 is 6. Sorry, 6 is the answer. 12 by 2, that is, you will get a total number of spectral lines as 6. That is a total number of spectral lines. Now you have to calculate number of lines in the UV region. UV region means what? Lyman series. Do you have any Lyman series for this transition? In order to have a Lyman series, we should get a transition to the first shell. But the electron is jumping only to the 3rd shell. So there will not be any Lyman series. So 0 lines. Now the number of lines in the visible region, we know that visible region is with regards to the Balmer series. So for Balmer series, n1 should be equal to 2. But the electron is only jumping to 3. That means there is also no Balmer series. 0. Now we will move on to number of lines in the Passion region. Yes, Passion region means it is a 3rd shell. So we can calculate the number as n2 minus n1. n2 is 6. So 6 minus 3 equal to 3. So 3 lines is possible in Passion. And number of lines in bracket region, that is again n2 minus n1, that is 6 minus 4, that is equal to 2. For bracket, n1 is equal to 4. And for fund, we know that it is n2 minus n1, that is 6 minus 5 equal to 1. So a total we got it as 5 plus 1, 6 lines. Okay. Now the number of lines in the IR region. IR region number of lines is 6 because Passion, bracket and fund and Humphrey. Here Humphrey is not possible because the electron is jumping from 6. Okay. If it was jumping from 7, then Humphrey series will also be there. But unfortunately it is jumping from 6. So yes, Hadia Faruqi, very good. Now the number of lines in the IR region is equal to 6. So IR region means Passion is IR, bracket is IR, fund is IR. All these 3 regions are IR regions. So you can just sum up and find out the answer. So the answer is 6. Hope this is clear, students. and I'm happy to see your answers. Now see the next question. A certain electronic transition from an excited state to the ground state of hydrogen atom gives 5 lines in UV region. How many lines does this transition produce in IR region? It's a very good question. See, first of all, you have to understand this. We do not know what N2 is. So N2 is not given. But we are given an information that it is excited from a ground state. That means the transition is from an excited to ground state. So ground state means N1 equal to 1. So here it is N1 equal to 1. And for this transition, we got what? 5 lines in Lyman series. 5 lines. That means we can write it as N2 minus N1 is equal to 5. Okay? And N1 is equal to 1 for Lyman series. We know that it is 1 for N1 equal to 1. So N2 minus 1 equal to 5. So we got the value for N2 is equal to 6. So here we got the value of N2, that is equal to 6. Now here they are asking how many lines does this transition produce in the IR region. See, for IR region we know that if N2 is equal to 6, then N1 should be equal to 3 for the IR region, because N1 can be 3, N1 can be 4 and N1 can be 5, and these 3 transitions corresponds to the IR region, right? So we can use each steps to find out. So first we will calculate the number of lines in the passion series, number of lines in passion, how much it will be is N2 minus N1, that is 6 minus 3, that is equal to 3, and number of lines in bracket, that is equal to 6 minus 4 equal to 2, and number of lines in fund, that is equal to 6 minus 5 equal to 1. So you can total this, you can sum this total of 3 plus 2 plus 1, total 6 lines are present in IR region. Or if you know the concept, that is from 3 to the higher energy state, it is IR region, then you can simply use this formula, that is the total lines formula, that is N2 minus N1, that is 6 minus 3 into 6 minus 3 minus 1 divided by 2. So here you will be getting 3 into 2, 6 by 2, that is 3. So that formula cannot be used, right? So why that cannot be used? Yes, we have to individually find out. If you use 3 here, then we are just getting the answer as answer for the lines in passion series. So we will not use that. But in fact, sir, is it sufficient for NEET 2022? Yes, why not Hadia? Hadia, right? Yes, why not Hadia? It is sufficient. See, yesterday's JEE paper, chemistry was so easy. It was so easy. I haven't seen such an easy paper for chemistry in the previous years. Have you seen that? So I hope the NEET exam, NEET chemistry also will be very easy. Okay. So we actually this question is a mains level question. If you can do this, then obviously what happens is that you can you will easily get the answer. Okay. Now the problem was I just wrote the formula in the wrong way. That is, we can find the same way as 6 minus 3 into that, just find the total number of lines from 6 to 3. That also makes sense. 6 minus 3 plus 1 it should be. I wrote it as minus 1. That's why we didn't get the answer. So 3 into 4 by 2. 3 into 4 by 2 is 6. So in order to find out the IR region, you just know the transition between where you will obtain IR regions, that is from 3 to higher energy, it is IR. So now the electron is jumping from 6. So in order to get the IR region, it should jump from 6 to 3. So just calculate the total number of spectral lines from when it jumps from 6 to 3. You can use this formula and find the value as 6. This method may take a bit more time. So if you know the concept, then you can directly apply this one so that you will get the answer in seconds. Right? Okay. Now let's start with the hydrogen spectrum. See, hydrogen spectrum, we have completed the emission spectrum. Now we are going to discuss about the absorption spectrum. Okay, Hadia. Now we are going to discuss about the absorption spectrum. I wanted you to do more problems, practice more MCQs. You can follow the lecture, you understand the concepts clearly, you can ask your doubts, clear your doubts, do practice more problems. Okay. That is what the core part of your preparation for NEET or as well as for JEE. The one thing is conceptual clarity, that I guarantee you, that I can give you. Okay. The second part is practicing. That's what you have to make sure that you will follow. Okay. So whenever you get a lecture, you watch a lecture, you understand the concepts properly. If there is any doubt, you can come to the comment section and just put it as a comment. I regularly check the comments. Or else you can join our Telegram channel. There you can ask questions. So we can clear that. So if that happens, then the second part is in your hand. That is, you have to thoroughly do more and more problems and focus on solving more questions so that you will be very much knowledgeable in the aspect of solving MCQs. Okay. That's a very important part you have to follow. Now, let's coming to the hydrogen spectrum, that is absorption spectrum. We already completed the hydrogen spectrum from the emission spectrum part. Now, the absorption spectrum. Here, the basic concept is that absorption of hydrogen only takes place from first shell. Normally, students make a big mistake. You know, the electron in the hydrogen atom is only present in the first shell. So absorption means your N2 will be 1. It cannot be any other number. N1 can change, but N2 will always be 1. Why? Because it is absorbing certain energy and it is exciting. So excitation only takes place when the electron is in the first ground state. Absorption of energy takes place when the electron in the first energy shell. So absorption spectral lines starts from 1 only. In any case, it's 1. Okay, that's what you have to remember. That means absorption spectrum will always provide us with the Lyman series. Only Lyman series we obtain for the absorption spectrum. No other series is present in the case of absorption spectrum, since N1 will always be 1 for absorption spectrum. Hope that is clear. So we can have similarly 7 lines. We know that maximum of 7 lines we draw. So 3, 4, 5, 6 and 7. So you can just consider the electron is present in the first shell. Always for the case of hydrogen atom, the electron will be present in the first shell. Now the electron can excite to the second shell, or from first shell it can excite to the third shell, or from first shell it can excite to the fourth shell, or from first shell it can excite to the fifth shell, or from first shell it can excite to 6, or from first shell it can excite to 7. This is how absorption spectrum works. There is no absorption spectrum from second shell to third shell. No, that never happens. This is wrong. Only absorption spectrum happens, or absorption spectrum is only obtained when an electron is absorbing certain energy. When it is present in the ground shell or in the first shell, then it excites to the higher shell. Okay. So after excitation, electron will move other shell. No, that's what I have told. After excitation, it do not move to other shell, but after excitation, it can come back to other shell. If it is coming back, then it is not absorption spectrum, it is emission spectrum. Okay, hope that is clear. See, if the electron is absorbing certain energy and it moves to the second shell, then again absorbing and moving to the third shell is not possible. That is not possible. Okay, that doesn't work. But if an electron is absorbing certain energy and it gets excited to the second shell, then there is a possibility that it can come back to the first shell by releasing that energy. Then that is the emission spectrum. First, it has given us the absorption spectrum by exciting to the second shell. Then second, it has given us the emission spectrum by coming back to the first shell. Is that clear, Hadia? Okay. So, in between absorbing, that is in between the shells, electron present in between the shells and absorbing certain energy and exciting to the higher energy shells is not possible. That's I have told you, this is not possible. Right? Either it excite from first shell to the last shell, or it excite from first shell to the sixth shell, or it can excite from first shell to the fifth shell, fourth shell, third shell, second shell, likewise it goes. But the excitation can only takes place from the first shell. That's what you have to remember in this concept. Okay, now let's see. Here we know that this is K shell, this is L shell, this is M shell, this is N, O, P and Q. Now this energy difference. See how much energy is absorbed by the electron. That's what you have to understand. The energy absorbed by the electron will be equivalent to the energy difference between the two shells. See, if an electron want to jump from K to L, how much energy it should absorb? It should absorb the energy that is a energy difference between L and K. See, if in case if L shell is having an energy of 100 joules, say for example, and K shell is having an energy of 50 joules. If an electron is present in the K shell, it wanted to excite to L shell, then how much energy it should absorb? It is already having 50 joule. Now how much energy it should absorb? It should absorb an energy difference of L and K, that is 50 joule. If it absorbs, it can excite to the second shell. Okay, so this we have calculated and we got a value that the energy difference between the electron is the shells is 10.2 electron volt between L and K. Between L and K, the energy gap is 10.2. That means for an electron to excite to second shell, from first shell to second shell, it have to absorb an amount of energy equivalent to 10.2 electron volt. If it is absorbing an energy of 10.19 electron volt, then excitation is not possible. Unless until if it absorbs an energy of around 10.2 volt, electron volt, then only it will excite to second energy shell. Now we will compare the third energy shell and the first energy shell. We will get a value of 12.09 electron volt. Similarly, the next one is fourth and the first. We will get a value of 12.75. Then likewise it goes, and the final value is 13.6. The last value is 13.6. That is the last shell and the first shell. The energy difference between last shell and the first shell is 13.6. Okay. So these values you have to keep in mind. These values. So an electron jumps from 1 to 3 only when it absorbs 12.09 electron volt. It jumps from 1 to 4 when it absorbs 12.75 electron volt. Electron jumps from 1 to the last shell, that is the seventh shell, when it absorbs an amount of energy of 13.6. Hadia Faruqi is asking if absorb 12.5. See Hadia, if it is absorbing 12.5, actually that case is not possible. Only electron can actually absorb this much particular amount of energy. Okay, it is very specific that it can absorb this much amount of energy. And also I can also give you this point also, that if it is absorbing 12.5 electron volt, say, this is a very good question, it will absorb 12.09 energy. It can only absorb the exact value. The other part of the energy, that means 0.41 electron volt is remaining. This 0.41 electron volt is converted into the form of kinetic energy. That means it get excited to the fourth shell and start moving. This kinetic energy will pushes the electron to move in that orbit. Okay, so that is what you have to understand. It will only absorb the certain amount of energy which will enable them to jump to the higher energy shell, and the other part of the energy is converted into kinetic energy. Okay, you are asking why, sir? I hope that is clear. That kinetic part is what you have to understand. If that kinetic part is understood for you, is it clear for you, then the concept is clear. Okay, now one more point here you have to understand is that if you are providing an energy greater than 13.6 electron volt, if you are providing an energy greater than 13.6 electron volt, Hadi, is that clear? Your why question is still remaining there, because see, the electron can only absorb an energy which will help them to move to the second, third or fourth orbit, where the electron should lie. The electron should lie in those orbit where the angular momentum is equal to the integral multiple of h by 2 pi, right? H by 4 pi. Now we know that there are 7 periods, or the 7 shell, that is corresponding to the to this concept, that is the angular momentum, according to what Bohr said. Okay, so there are only 7 shell. If the electron is absorbing a value of 12.5, where it will end? It will end between the third orbit and the fourth orbit. Is there any orbit between 3 and 4? No. So it cannot absorb that certain amount of energy. What they will do is that they will absorb 12.09 electron volt energy. They excite to the third orbit, and they use the remaining energy of that photon into the as the kinetic energy. Okay. Now here you have to understand, if I provide 13.6 electron volt, then the electron will excite to the 7th shell. It will excite to the 7th shell. If I am providing an energy greater than 13.6, then the electron will move out of the atom, because we consider the 7th shell as the last shell. If you are providing an energy greater than 13.6 electron volt, then it is obvious that the electron will move out of the atom. That means the atom gets ionized. It converts to a cation. Okay? Yes? Now we'll move on to the next one. See, this is the note that it corresponds to what we have discussed. That is, the transition in absorption spectrum of hydrogen always occur from ground state only. Okay, that we have already told. There is no intermediate excitation. It always excites from ground state to the higher state. That means only that protons are absorbed which are of energy 10.2, 12.09, 12.75 electron volt. I have told this point. This is what Hadia has very clearly asked. Okay, this quantity of energy can only be absorbed by electron. If additional energy is present, then that is converted into kinetic energy for the movement of electrons. Because if it is fully absorbing that energy, it cannot excite to any orbit. Okay, it can only excite to that particular orbit according to the Bohr concept, which is an integral multiple of h by 2 pi. That's only is possible. Okay, so we have classified that 7 shells or 7 orbits which corresponds to what Bohr has explained. So there is no intermediate energy shell which helps the electron to orbit the nucleus. So we only have that 7. So we can only, the electron can only absorb those 7 energies or those 6 energy values to reach to that energy shells. If it absorbs energy more than the required, then the required energy is used to utilize them to excite to the particular energy shell, and the remaining part of the energy is converted into the kinetic energy. But when an electron having energy more than 10.2 electron volt strikes on hydrogen sample, then it will be absorbed as extra energy and may be converted into kinetic energy. Yes. Now, number of absorption, I have already told, number of absorption is equal to number of Lyman lines equal to N2 minus N1. So, absorption is always what? Absorption is always number of Lyman lines. Okay, how many lines we got, how many absorption spectrum we got, it is equal to number of Lyman lines. The formula is N2 minus N1. Now, let's move on to the next one. In an atom, 5 orbits are present. In an atom, 5 orbits are present. Then calculate the number of emission lines and absorption lines formed in the spectrum. So, number of emission lines, they are asking about the total number. So, number of, yes, if less than the required electron, then will not move. At least 10.2, here we have mentioned, at least 10.2 should be there. If you are providing 10.19 electron volt, it will not excite. At least 12.09 you have to provide in order to jump to the third shell. If you are providing 12 electron volt, then what happens is that it will excite to the first shell by using 10.2 electron volt, and the rest will be utilized as the kinetic energy. Okay. So, if an electron have to excite to the, at least it has to excite to the next shell, you have to provide this much. If this much energy is not provided, then electron will not absorb that energy. It will not take that energy. It will still remain in the first shell. Hope that is clear, Hadia. Now, number of emission lines is asked. That means you have to use the formula of the total lines. They haven't mentioned any particular series, so you have to find out the total lines. Now, what is the total line? N2 minus N1 into N2 minus N1 plus 1 divided by 2. So, what is N2 minus N1? N2 is 5. There are 5 orbits. So, you have to calculate the absorption spectrum. So, if for understanding the absorption spectrum or the absorption lines, we know that the electron should jump from first shell. So, N1 will always be equal to 1. So, from that data, we can just take N1 equal to 1 because they are asking about absorption lines also. So, in order to get absorption lines, the electron jump from first shell to the higher shell. So, N2 minus N1, N2 is 5 minus 1, 5 minus 1 plus 1 divided by 2. So, 4 into 5 by 2, that is 20 by 2 equal to 10. Yes, crystal clear, very good. Okay, now we got the number of emission lines equal to 10. Now, let's calculate number of absorption lines. For calculating number of absorption lines, we only have to calculate the number of Lyman lines. That is N2 minus N1, which is equal to N2 is equal to 5, N1 equal to 1, that is equal to 4 Lyman lines, or we can say that absorption lines is equal to 4. Okay. Now, let's move on to the next question. If 9.9 electron volt energy is supplied to hydrogen atom, see Hadia, this is a previous year question. If you know the concept, you can easily answer this. Okay, let's seeing this question, reading this question, just comment your answer. If 9.9 electron volt energy is supplied to hydrogen atoms, the number of spectral lines emitted is equal to. Emitted is equal to. How much will be the answer? See here, you can see that first of all the lines emit for any yes, very good, it's the answer is 0. It's a previous question. Answer is 0. For any lines to be emitted, first of all it have to excite, right? For emission lines, they are asking about emission lines. For emission lines, they have to, the electron have to come back. So we are providing 9.9 electron volt energy. Can the electron take up 9.9 electron volt energy? No. At least 10.2 electron volt energy should be supplied. Then only it can excite to the first shell or second shell. Okay. But here we are only providing 9.9 electron volts, so we will not get any spectral lines, whether it is emitted or absorbed. First of all, we get absorption spectrum. Then only we are going to get the emission spectrum. I'm happy that you have answered it very correctly. Now I am clear that the concept is clear for you. Now let's do this problem. If a photon of energy 14 electron volt is incident on an atom, what is true? Yes, at least 10.2. Very good. What is true? We know that 14 electron volt means, that means we know that the maximum amount of energy is 13.6. If you are providing more energy than 13.6, that means the electron will get excited or the electron will move out of the atom. That means the atom will get ionized. Okay, 13.6 corresponds to the topmost 7th shell, right? I have told you from first shell to 7th shell the energy required is 13.6. If you are providing more energy, then the atom will get ionized. That means the electron will move out of the atom. So it will move out of the atom, so the atom will be ionized. And what will be the kinetic energy? Obviously it will be equal to 14 minus 13.6, that is equal to 0.4 electron volt energy will be the kinetic energy of that electron. So the answer is 2. Now the last question. An electron of energy 10.8 electron volt is incident on an hydrogen atom. Then first let's see the first option. The electron will come out with 10.8 electron volt energy. Wrong. The electron will be completely absorbed. The energy will be completely absorbed. That is wrong. 10.2 electron volt of the energy would be absorbed by hydrogen atom. This E stands for actually energy, right? 10.2 electron volt of the energy would be absorbed by hydrogen atom, and it would come out with 0.6 electron volt energy. Yes, option 3 is the right answer. Adya is saying 2. Maybe the previous one. Yes, you might have given the previous one. So 10.2 electron volt of energy would be absorbed by hydrogen atom, and it would come out with 0.6 electron volt of energy, means kinetic energy. Yes, 3 is the right answer. Very good, Hadia. So hope this is clear. That's all with today's lecture. We have covered the hydrogen spectrum. From atomic structure, we have covered Bohr model, we have covered the hydrogen spectrum, that is both the spectrum, absorption as well as emission spectrum. Now in the next class, we will be discussing about the quantum mechanical model and the quantum numbers. Okay, hope this class was very useful for you, and if you have your friends, you can also suggest them. If you like the classes, share the link with them and also bring them to our platform so that they can also learn. Okay, so thank you guys, you are so amazing, and let's meet in the next class, inshallah. Thank you, have a nice day.